VR, AR, XR. The focus of this day one panel was to explore virtual, augmented, and other enhanced reality technologies, including their evolution and directions they may take in the future. Speaker bios are at futureofinterface.org/bios.
This panel is going to address the question of extended reality or augmented reality and virtual reality, trying to look 20 years ahead. And I want to ask the panelists to try very hard to push your potential that you see for these technologies farther ahead than today's world, if you can. We've been stressing the point of looking farther ahead and to try to understand what barriers might be in the way of reaching an effective use of these technologies in a couple of decades' time. I have with me on the panel Amitabh Varshney, who is at the University of Maryland, Andy Wilson from Microsoft, Hiroshi from the MIT Media Lab, and Jaron Lanier, who is also from Microsoft. And I'm deliberately not giving much in the way of bio here. You can read those biographies. They've been provided ahead of time. But I can tell you that these are accomplished and I would say visionary people who are appropriate for this panel. And I'm going to start by just asking each one of you, and I'll go in a particular order, each one of you to say something about where you think we are likely to be or could be in these technologies, XR, AR, and VR, literally 2 decades from now. And Jaron, I'm going to start with you because you have historically been very good at looking farther ahead than most other folks. So let's see where Jaron takes us in 2 decades.
In something like 45 years ago, I suppose, was when I started working on this stuff. And at that time, a core part of the idea for what we called virtual reality was that people would be able to spontaneously make up not just the static content, but the dynamics and the interactive elements as they went. It would be an act of creation, not reception, or it would be a more active sort of medium than previous ones with spontaneous creation. And at the time, I usually imagined some sort of emotion to simulator transformation. So for instance, you would play a virtual musical instrument and virtual worlds would be created and changed as a result of playing the instrument. And I did a few demos a little like that, but the established level of both hardware and software capability at that time didn't allow for much of it. I'd always viewed virtual reality as in a way in contrast to language, in the sense that in language you have somewhat arbitrary symbols that stand in for things, like you have the word cat standing in for a real cat. And I'd imagined this was the notion of post-symbolic communication, that you'd have more direct creation of stuff in virtual reality and less use of symbols. But despite that, we're at a moment now where text-based prompting has started to work for things. And so I've been interested in applying it to virtual reality. There's a couple of a major problem has emerged over the decades, which just really hasn't given way, it hasn't yielded. And that is that virtual reality stuff is just incredibly hard to develop and especially hard to maintain. That if you look at text-based prompting that's been recently popularized for creating images or in chatbots or for code generation, in all those applications, those were things people were already doing effectively. And we can say, well, if we can do it in this new way with, I like to call it mashup AI instead of prompt-based or generative, but if we can use mashup AI and do these things in new ways, great. But it's not like we couldn't do them before. But arguably with VR, we haven't really been able to do them before. If you look at for instance, since the 90s, at least, people have been building virtual reality experience tools to generate intuition about how general relativity works. I think the first one might have even been in the 80s. And I'm not aware of a single one of those that's ever persisted more than a year or traveled from its lab of origin to others, or been widely downloaded and remained usable from somebody's online store, because these things are really hard to maintain, and they have this fragile temporary quality. So because of that emerging problem in the software development, and because of the original agenda, which I can't quite give up on because I'm still a kid inside who believes in all that stuff, I guess, this notion of trying to unite the current prompt or mashup AI craze with UI is something that fascinates me. So we started about a little over a year ago, I guess, doing that. And the initial target has been a game that Microsoft has called Minecraft that's popular, which is a great target for it because it's intrinsically got a low res aesthetic with these, I'm sure everybody knows it. So it's a kind of an easier target than and so we've been doing a lot of sort of Minecraft generation, and then our friends at places like Google and Meta have also been showing game generation. There's quite a distinction between doing prompt-based game generation and VR, because VR requires the interactivity component and requires whole scene dynamic coherence to a greater degree usually than games do, which are sort of more focused on particular dynamics related to the next stages in gameplay rather than a complete simulation that doesn't anticipate any particular behavior more than another. So we had our first papers recently. We had something in NeurIPS, and the triumph for me. So the test bed I set up is virtual tennis, where people are playing tennis, but while the ball's in motion, each player can ask the ball to change into something, or can ask their hand or the racket to change into something. So, for instance, we had one example where somebody said, ball, you're turning into a salmon, or whatever they said. And I thought it would be a fish, perhaps, but it turned into a salmon steak. And then the other person said, my hand is a Ginsu knife, and their hand turned into a knife, kind of like in some science fiction thing. And then they sliced it. And the interesting thing about that is, in order to make this work, you have to do this very multimodal thing where you're going back between text generation and image generation for feedback to get the whole thing to work, and then code generation. And by going through this multimodal thing, it got to the point of synthesizing code to take one 3D object, which was a salmon steak, and cut it into two when the knife sliced through it. So you ended up with two of them instead, which to me is exactly the kind of thing that needs to be supported. So we have a long way to go, but I guess if our topic here is about accessibility, I guess what I want to say is that the difficulty in developing and adapting and maintaining virtual reality at all has also translated into a real brittleness and rigidity in adapting it to individuals. And so what I'm kind of hoping we'll get to in the future is a mashup AI or prompt-based approach. So somebody can come in and say to a virtual world and say, hey, I only have one hand. Make this whole thing work for somebody with one hand, and it'll synthesize it reasonably well. And that's something I think is reasonably achievable, though not perfectly, and in a reasonable time frame, though not instantly. And I don't think it's something we can do at all without it. So in a way, it's the most compelling use case for this prompt-based stuff. And I'm feeling kind of hopeful that there's a synthesis coming together now. We have a long ways to go. As far as the instrumentation,
Jaron, I apologize.
am I taking too much time?
Yeah,
I'll stop. I can stop.
What you've done, though, is to pinpoint something absolutely fascinating, and that's the possibility of using the techniques you just described to synthesize accessible interfaces.
Exactly.
That is a new idea. It's not something that I have heard before from anyone. So let me thank you for that. We'll part of our conversation. I want to go on now to Hiroshi Ishii. Hiroshi has some slides to show. So Hiroshi, I don't know whether they've enabled you to show slides, I hope so. Is I may need some help from Crystal. I don't see, oh, there, share screen is available. Are you
Hiroshi,
having?
remember to turn on your mic too, Hiroshi.
Yeah, don't forget to turn your microphone on. This is, we can't hear you.
Okay, sorry. I'm just starting a slide. Give me one moment.
This is the wonderful thing about the way these video conferences work. You get to watch the other people trying to figure out how to use the interface. Sometimes I think the people who design applications should have videos of people trying to use their applications, and that from which they will learn how well or poorly the interface actually works. Okay, we're seeing something.
Can you see my slides?
Yes, we can.
Great.
Go ahead.
Thank you very much. Today, I'd like to focus on the AR, augmented realities, how to really bond the computation more deeply into the physical world. So instead of the metaverse, I call it the metaverse. So my belief is representation of idea information really matters. It's very abstract, pixel-oriented representation has fundamental limitation to engage people. The best example is orally, that the people can grab the handle, then rotate. The whole solar system is synchronized with the body movement. Also, you can see where your partners, students are looking at, where teachers are pointing at. So this is the beauty of the physical world. How to combine computation into this physical world, something important. But 1995, Nicholas pushed to the more digital domain, like being digital. Then I try to push back to more tangible. So I see this panel is so exciting because I see interesting pendulum moving between digital world, also physical world, tangible bits, and also these days, virtual reality become huge movement, and also metaverse make a huge hype. But I'm very interested about how to bring back to more physical world. We are grounded. So that I call metaverse. I borrowed this term from a Padrex conference last November in Barcelona. So I think basically we're in a seashore between bits of the information, also atoms of the physical world. Then there seems to be two different paths. So VR definitely go to the deep sea diver because we can't breathe in the water. You need oxygen. You need a life-saving pipe. But on the other hand, I much prefer to become strollers. I much prefer to walk in the seashore, enjoying the breeze of the wind, seeing each other's eyes, also picking up a seashell rather than go to the diver. But I think I was looking for the model, and I found that these are two interesting metaphorical models of immersive environment. It's not virtual, it's real, also hybrid. One is a big aquariums. Also another example is a immersive Frida Kahlo or immersive Van Gogh exhibition. This is a really great example to think about those worlds. So we are very much interested in talking about how to make digital tangible so that it can also more integrated into the digital world seamlessly. So I'd like to show a few examples of the system. So this is a system called Up that Dr. John Rockefeller did it. This is an architectural model. It's a physical, but the shadow is a digital. So you can really blend graspable, tangible interface with projection mapping. This is another example of the landscape design. You can use real handbox or clay to sculpt using your hands, but still project the water drainage, for example, with analysis. So you can combine physically manipulable materials and also the digital computation together. So this is a new system I rebuilt after 20 years for the MIT Museum exhibitions. It's very important that to engage kids. So another example, my dream is to push into that. Can you see the video moving? Can you see the video on the paintbrush? Yes, we can. Okay, so this is the airbrush that anybody can invent. So rather than diving into the digital world. So Another example is, for example, we can really change the surface of the architectural space to interactive space. This is a Ping Pong Plus project I did almost 20 years ago. Many people did AR, projection mapping. But I think this is the direction I much prefer to dive into the real physical virtual world. Then another two example is using a dynamic shape changing display. So we started radical atoms after Tangibles to make a real physical object behave like a pixel in a screen. Now you can see the shape display become an extension of the remote function. So you can really. Last piece is a last piece is another system called transform, but you can see the dynamic physical object model. So in short, we believe there's a new direction in which we can really make a physical world, dance, or this. So I think it's interesting to think about the opposite of the VR, dive into the computer-generated immersive world, but bringing computation grounded to the real physical world, especially materials. So I believe a human-material interaction becomes an interesting future to make AR to take off to the new direction. So thank you, and sorry for the sound.
That's okay. Thank you very much. Those were very thought-provoking, and I'd like to suggest that what you've just shown us, trying to project now forward for 20 years, suggests that a lot of the interaction that we might have with artificial intelligences can be, as you've demonstrated, much more physical than simply images, sound, and text. And so that certainly sets my mind thinking about the way in which we design accessible interfaces using physical mechanisms in addition to visual and audio. Thank you. So that's actually very thought-provoking. Let's move on to Andy Wilson. Andy is, there you are. I was afraid you disappeared. So Andy, what's your sense of where we can go in 20 years with the AR, VR, XR space?
Well, yeah, like I love both of the directions that Hiroshi and Jaron are suggesting. I think they're both like super interesting. I think one thing that hasn't been mentioned yet is like in the next 20 years, I think we need to settle this whole issue of whether or not people are going to be working in VR. And by that, I mean like, what does the headset look like in VR? We have this idea, I think, that's been suggested that in order to go to work, you put the headset on. Now, there are a number of technical problems there, like fidelity of text and battery life and all of those kinds of things I think will be addressed in due course. So I'm not too worried about that. I can imagine that we'll get to the point where you get the thing is very much is smaller and the ergonomics will eventually kind of get much better. But one of the problems I think, of course, is that it really kind of shuts you off from the real world, right? Mm-hmm. And if you've played around with Facebook's Horizon Workrooms, I mean, it's a brilliant, it's a really nicely done experience. You look to your right, you look to your left, and the person's right there, and you want to talk to them, and the spatial audio is really good. But that doesn't really work if you're in that kind of if there's somebody else in the room with you at the same time. So we either are going to go into this weird space where everyone's meeting virtually, or we have this sort of uncomfortable phase where we're not really going to be using headsets in our daily work. We'll be using some other things, but that's okay, because I think the stuff that Hiroshi's been working on and that I've been sort of working on as well is like the idea that you can push some of those features of VR but into the real world, using other kinds of display technologies. Hiroshi, I'm so happy you showed the ping pong plus system. I was digging around trying to find the circuit board. I actually in the process of rebuilding that system with my kids. I have the circuit board like right here. Actually, it's within reach. I have some questions about it. No, never mind. So being able to like generalize beyond VR. Rob Jacob at Tufts called this reality-based interfaces, and I kind of like that moniker. The idea that you can do VR-like things. You draw on reality for the way that it should should work in terms of presentation and interaction. And I think that goes beyond kind of natural user interfaces, and might have features like the fact that when you render somebody, you try to render them life size on the screen, right? And the way that you would interact with them, might change a little bit just because you're rendering them in life size. Or, talk to gamers, and they know all about these things, right? They're immersed all the time, and so I don't think you necessarily need a headset in order to have some of those features of VR. And that, of course, has implications for accessibility. The idea that you can, author an experience, perhaps using approaches that Jaron suggests, and that they would, light up on a big screen or on your wall at home or at work on a phone in VR, on a VR headset. And it would all just sort of run the same system. We're not there today. So I think that's kind of the direction that I'm thinking. I hope that we have some progress on that in 20 years. One system that I've have been working on is this. You put the VR headset, and then you are in a fully virtual experience, and yet you see aspects of the world that are rendered into the game in a way that's thematic to the game. Part of that is just safety. You don't want to be tripping over your coffee table, and you don't want to trip over your coffee table and bleed out on the floor, right? Sitting next to somebody or seeing somebody who's walking into the room is really important. And so I think there's this idea that you could, selectively bring rendering into the experience. Sort of, it's not necessarily about opacity. There's not going to be a dial on your headset that just changes opacity. There might be a dial on your headset that selects like what kinds of objects you want to see, right? Or how, what is kind of the threshold that you want in terms of, do I care that my cat has just entered the room? Anyway, so I think those are the kinds of directions that I'm interested in. Well, let me finish that one idea of that. Then as you see objects that are in the real world rendered into that virtual experience, you might decide, well, I'm gonna take that headset off, I'm gonna put it down, and then that immediately moves over to another display in the world, right? So it might project onto your wall, it might be on a display, it might be on your ping pong table, I don't know. So I think there's a way that we can talk about moving those experiences and have a kind of certain fluidity to that. And there's lots of systems issues, and I don't think the people that are authoring these experiences are necessarily thinking about that right now. They're kind of targeting a given form factor and making it the best that it possibly can be. And that's how they work. So having a way to transcend some of these things and develop kind of a new framework and around which you can move across devices is something that's challenging.
Sorry. Go ahead. I didn't mean to cut you off.
No, that's fine. I have another sort of direction I can go into that I'm thinking about, but maybe we need to move on.
Yeah. Let's hang on to that. Keep your powder dry. Before we go on to Amitabh, I just wanted to make an observation. You made me think about teleoperation, for example. And when we're speaking about accessibility and things like that, the ability to manipulate the real world to bring or augment the real world by bringing information and capability to someone who has difficulty with real world interaction seems like it might be much more feasible as we look towards the future, so that people can augment their inadequate capabilities or insufficient capabilities with mechanical capacity. The other thing you mentioned is augmented reality. I get very excited about that because you have the possibility of being able to learn about the real world that surrounds you because you have information about it. Imagine if you're blind and have the ability to have face a particular direction and say, what building am I looking at? Things along those lines feel like they are augmenting in ways that we could hope, 20 years from now to be a natural, a natural feature of some of these systems. So Amitabh, let me give you a chance to sort of give a framing view from your perspective about where these technologies could be in 20 years' time.
Great. Thank you so much, Vint and Greg, for inviting me on this panel. And Jaron, Hiroshi, and Andy, you guys are a tough act to follow. You have said much of what had to be said, but let me give it my best shot. So I wanted to focus. This is a very brief slide deck of two aspects of VR, AR, which are related to display and cameras that I wanted to talk about. So here are some of the display technologies we have available right now. Stereoscopic displays like the headsets, light field displays, varifocal displays, and holographic displays. Right now, most of us are focused on the head-mounted displays for a variety of reasons. One of them being they are so compelling in their present incarnation, and they are allowing us to create a sense of excitement and wonder amongst the greater population. However, we have all struggled with a lot of the challenges with the headsets, the way they are currently structured. They have limited number of focal planes. They have a vergence accommodation conflict challenge. The varifocal displays, on the other hand, can allow a variety of focal distances, but they are bulky. They often contain moving parts. Not always, but sometimes they do. And the light field displays, at least in the way they are currently structured, they have limitations on the spatial resolutions and focal distances due to the optical diffraction that they have. At the same time, because of the rising numbers of pixels, both in the pixel density, as well as the increase in the field of view in these displays, as well as the progressively higher and higher refresh rates that are needed, or that we have found are needed to maintain this illusion of presence in virtual environments, we have this pixel refresh rate challenge that is coming before us, where the number of pixels that need to be updated every second are rising at a pretty dramatic rate. So with all this as a background, I wanted to suggest that the future, 20 years from now, the target that Vint and Greg have given us, is going to be holographic displays, where they are reconstructing the entire light field. They will not have to worry about the vergence accommodation conflict. We'll be able to focus at different distances, and we will be able to trade off the spatial and the angular resolution of these light field displays. So where are we with this right now? At this time, by far, the most common technology for this, the most commoditized version of this, is the liquid crystal on silicon spatial light modulators, or LCOS SLMs. And these have reasonably good refresh rates at around 180 hertz or so. But what is emerging right now, which I think would be very exciting, are these nanophotonic phased arrays. This is something we are working on, and I'm really excited about these. They are integrating light source and antennas on the chips. They are giving you phase modulation. So imagine a display where every pixel is emitting an amplitude and a phase for the light waves emitting from that pixel.
Yeah.
These nanophotonic phased arrays, or NPAs, are capable of supporting 100 kilohertz refresh rates. We have built a prototype right now in the lab. It's very small, but the basic principles in the visible light spectrum, we have tried the red light right now, red lasers. They are working, they are provable, and a lot of challenges still remain. But if you're again looking at a 20-year time horizon, a lot of these can be solved. One other thing which is very exciting about these on-chip phase amplitude displays is because each pixel is now giving off a, think of it as a light front, a wave front of lights. You can do some very interesting things. Remember, I was telling you a few slides ago about the pixel refresh rate challenge. Well, one of the things we found, much to our surprise, with these is you don't need to turn on all the pixels. Because you now have phase along with amplitude, you can achieve very similar high quality images with only 10% of the pixels active.
Wow.
So this is, it could solve the challenge, Andy, you were talking about the battery constraints that these would be solved. And this is one of the technologies that could hopefully take us there and also free us from this constraint right now of every pixel has to be on. There's a one-to-one correspondence between displayed pixels and the image formation on our faces. The other thing I wanted to bring up is these holographic cameras. A lot of us are working on volumetric capture studios. We have one at the University of Maryland. And look at this kind of a display. And now if you try to project it 20 years out, one of the things that seems apparent is with the drop in the camera sensors, the cost of the camera sensors, the drop in the advances in the semiconductor fabrication technologies. Why can't you imagine a future where camera arrays are like wallpaper, communicating with each other using Bluetooth, attached to the environments around you? When you were talking about teleoperations and telepresence, these kinds of displays, these kinds of cameras captured around could give us the raw data, which using latest incarnations of generative AI could help us animate them and interact with these. So with these, that's sort of a high level view. I think we have come a very long way in building low cost, practical and compelling virtual worlds. There are a lot of applications, but many more need to be investigated where they can be a clear immersive benefit, immersive advantage to having these kinds of displays. And I think we are looking forward to some very exciting times ahead. And I would love to discuss with the panel as well as the audience on how we can prepare ourselves the best for this exciting future ahead.
Wow, this is Vint again. I have to tell you that this is the first time I've ever felt like maybe the holodeck is not completely science fiction. And of course, I'm thinking about the low-cost wallpaper cameras. If you mix that with the nanophotonic phased array projection system in the same room, you have to wonder what the consequences of that would be. What happens when you take a nanophotonic array and you expose it to the hologram? And you expose the holographic cameras to the array. Does it get all confused?
Yeah, Vint, that is such an amazing idea. Up until the time you brought it up, we had not thought of it. But now that you brought it up, I think one very exciting possibility could be if the camera shutters could be turned on when the NPA array is not projecting. So one could interleave the two.
Wow.
So that for the human eye, it is a holodeck, but each one is seeing just what they need to see.
Okay, so let me shift gears. Thank you so much. That was really thought-provoking. I want to come back now to the panel and ask a few questions. First of all, I imagine if we were doing this interaction and we were doing it with our headsets on, we'd all look like Darth Vader. And so I suspect that's not what everybody wants. A few people like the idea, but most people probably not. But the implication is that as long as we're going to use headsets, that means that we are going to have avatars that we project in lieu of a camera image of us wearing a headset, which suggests there's a business to be made out of creating avatars for people And then the next thing, obviously, is they have to wear clothes. Well, maybe they don't have to, but assuming that you want them to wear clothes, I suppose you could rent a virtual Ralph Lauren suit for $5 a month. And so a whole new business comes in the creation of avatars and their clothing and other things that they have in this virtual environment. So 20 years from now, that may be a whole new line of business for some people. How far can we push this? What about haptics? Anybody want to say anything about whether haptics are a potential? And that is very important, especially in the event that you have someone who has a visual impairment, but who can usefully interact using haptic methods. Where are we with that? And is there anyone on the panel that wants to speak to that?
Can I make a comment?
Hiroshi, yes, because you've
Yeah.
been showing examples of this already, in a sense.
I think sense of touch is so important, not necessarily just grasping virtual object. If I'm thirsty, I want to grab the cup, but not just seeing, but also I want to drink it. So most important thing is if you imitate the reality as a pixel, fundamentally tactility missing. Then now there's a huge hype of the haptic technology. So many people invent amazing grab or suits, do very specific things, very limited type of the interaction. But in the end, that's the reason I say the deep sea diver. You need to see, but also you need to feel it. To do so, you have to augment entire body. So that is make technology less accessible. So one of the key of this workshop is how to make it accessible. It's more easy to use it. To do so, dive into the pure virtual stuff is something a bit tricky because fundamental lack of the haptic interaction. That's my point.
Well, certainly our bodies, this proprioceptive reality, I think, is important. It's the thing that causes us to feel sick when we wear a headset is that our bodies are not sensing the motion that the headset is showing us, and so we get confused by that. Do you suppose that, thinking about teleoperation for just a second, do you suppose that you might end up with a haptic environment or a suit and gloves and so on that deliberately designed in order to let you manipulate something remotely, which might be super hazardous, for example? I mean, we've done that with just hand manipulations and, the Waldo gadgets. But I wonder whether we could imagine people working deliberately in dangerous places remotely by the use of virtual reality and or augmented reality and the haptic mechanisms.
Yeah, that sort of thing, which goes by different names, is sometimes called telepresence, actually predates what we think of as virtual reality by quite a bit. There was a remote mining robot that operated on that principle in the 50s, developed by a company called Philco that didn't catch on. And there's some other very early examples. The trade-off we run into with haptic interfaces is if we want them to be anchored to the ground so that they can offer resistance between the person and the world, not just within a single hand, then we lock the person who's using them into a single place unless we can come up with some sort of mobile device. I used to have this model I tried to implement called the octopus butler robot, which would be octopus, meaning that it transforms shape like some octopuses can. And it's like a butler robot because a butler might show up with a tray just when you need it. And so it kind of puts a ground attached haptic interaction device in front of you just when you need it, and it would travel around next to you and all that. Such a device is imaginable, but probably not practical in the real world. So the issue we have is, can we ground to reality in order to have resistance relative to the planet, not to one's own body, and then also allow people freedom of motion at the same time? And that remains an implementation puzzle. It's definitely doable, but maybe not in a practical sense. it remains a problem. I mean, if you take somebody who needs a haptic interface and you tell them we can give that to you, but you have to stay in place next to this haptic interaction device, have we done enough? Or can we give them a mobile glove that includes some kind of force display in it? And is that thing that's only grounded to their own body adequate to give them what they need? I've certainly worked on both of those, as have other people on this panel, and that's where the puzzle has stood for some decades, and it's a fundamental physics sort of meets cognition problem. And it's not one of those things where we know the solution and we're just waiting for better technology. It's a thing where we really don't have a basic strategy for the puzzle yet that we're confident will work.
So thank you for that, Jaron. I'm wondering whether one could imagine a kind of direct manipulation, but driven in some virtual way. I seem to remember, for example, that IBM had an arrangement where you could interact directly using a device that was actually moving ions around in a microscopic way. And I guess think about the intuitive surgical Da Vinci robot is another example where you're directly manipulating the physical world, but you could imagine directly manipulating a virtual world. These technologies seem like they are already fairly far along. What am I missing?
The Da Vinci device, God, I worked on the prototype for that so many decades ago. But the Da Vinci device, once again, is grounded to reality. There's an arm that's attached to the real world, adjacent to the person, and that works great in a medical context because the doctor is also attached to a specific place because that's where the patient is. So in that application, there's no conflict. That works. However, once again, for a general thing, if you're telling somebody, well, we can give you a haptic interface, but you have to be next to this thing that's attached to the real world in order for it to give you force or resistance relative to the world, that puts a new burden on them on where they can be at all. So it does, there are specific professions where that's not a problem, and surgery is certainly, in a lot of other medical scenarios are ideal examples of that. But in general, that conflict is a significant one.
So Hiroshi, Andy, any other thoughts along these lines?
Can I make one comment? Because
yes,
before
please.
haptic, you mentioned about the avatar, and the avatars are wearing all the nice fashion. And I think I really care about telepresence, as Jaron said, how to connect people mediated by technology. Then trust is so important. And also hearing what engineer said, avatar, it's very realistic, also believable. And because photorealistic, having so many cameras, but making very precise photorealistic image is not necessarily be very trustable, because realistic can be also could be fake, also be even more scary. So many bad people hacking the system, so you can easily storm that identity. So believable and photorealistic sounds a bit scary. And also some people talk about the visual Turing test, that the indistinguishable avatar, but making avatar realistic doesn't make so much sense. If you talk about digital twin representing a city or car, it's okay, but the people different. So I'm still really have a big doubt about a virtual avatar making interaction, communication, and making a mutual respect, trust is something I'm very have a difficulty to believe it. Yeah.
Well, and I would add that I have a colleague who works in the education sector, and she pointed out to me that avatars are basically a non-starter in that world. Like teachers hate that. And it was like, it occurred to me, of course they hate it. Like that's a, like, so there's a really interesting challenge. I do believe in 20 years, we will have really interesting video codecs that will solve the problem you mentioned, Vint, of putting the headset on and then having a realistic version of yourself. I feel like that'll be a solved problem in 20 years. And that'll be, completely sensor and data driven and so forth. But there is, I think Hiroshi's right. I think there's a real problem of authenticity that'll be interesting to see how people deal with that. I mean, it kind of overlaps a little bit with some of the other things that are some of the other trends that are going on in AI, I suppose.
Well, you just put your finger on one of the most interesting trends, which is the ability to generate video, which is indistinguishable from the real world, but it's people who are no longer alive. And of course, the entertainment industry is extremely interested in being able to recreate actors that have become famous and are well known and so on. But that does leave you with this very uneasy feeling of what's real and what isn't, and what can I trust and what is fake, to borrow a term. Amitabh is smiling. I wonder if you have something to say about that.
I love this panel. It's so thought-provoking questions. So here are some of the. I mean, first of all, I agree about the trustworthiness of these virtual avatars and what can you believe and what you don't believe is a very important component. There are some cases. So one of the people we were talking with is a emergency physician in a shock trauma center at University of Maryland, Baltimore. And Dr. Seramati, she was telling us that imagine being able to have virtual avatars of somebody at home for a bedridden patient who these people cannot visit.
Mm-hmm.
Imagine how much of what a difference it would make in terms of the quality of life of this person who cannot meet their loved ones at a distance. For the education, there are some aspects which are interesting. So right now, when you look at the MOOCs that are available, and a lot of them are reducing the availability of the educator. Some of them, in some cases, the teacher is in a small circle at the bottom right of the screen. In some cases, the teacher disappears completely, and all you have is a pen writing, scribbling things on the screen. What happened to all this notion of inspiring role models in the classroom, and people where you could, who could inspire you to think as opposed to just know the facts? And so there is a room, I believe, for generative AI-based avatars as well as real-life avatars, learning to know what the differences are and looking at where each would be applicable and useful. I think we will need to work on that.
I want to come back to Andy for a moment because of something you said and I didn't understand. You said teachers hate avatars. Could you elaborate a little bit on that?
Well, I think they just want to know, like, how their teachers are, how the students are doing, right? And one of the ways that teachers do that is direct observation. They don't want the
I see what you're getting at. So the teacher is saying, I don't want a student avatar because they can't really tell how are they paying attention, or they okay.
Right. And this big experiment that we just went through the last 2 or 3 years, right, has given them an interesting point of view on this subject. And I think we need to listen to them a little bit.
Okay, so this is very interesting because here we are talking about, extended reality, augmented reality, virtual reality, and yet what you are telling us with that observation is that so far anyway, it has interfered with our ability to interact with each other and to connect with each other in a way that's useful. So now the question is, 20 years from now, do you think that's still going to be the case, or do you think that we will have found ways of making the avatar somehow more closely connect with the person as opposed to being an artifact?
Yeah,
I'm not sure I said that very well, but
no, I no doubt, like, things will have changed, and that the sensitivity around this will probably shift a bit in 20 years. I think that right now we're in this. I think the way people think about avatars is you're either using them or you're not. Like, you're either using video or you're coming in with, like, cartoon character.
Yeah.
That's sort of poorly rendered, and I think that's what we have today. If you look in what's going on in the labs right now, like there's a lot more that's going to populate that space between those two, endpoints. And so I think that there will be some, even if you just look at the issue around video compression is going to be, is already becoming very, hot again, using some of these newer models based around compression of, video of people. And so I think as those things come online and usable, I think people will eventually sort of become more accustomed to that, and that these things will slide a little bit, shift over time.
So I want to push a little harder into real world phenomena for just a second. How much farther can we go with this kind of virtual or an augmented reality? What about smell and taste? Those are two senses that are not so easy to artificially produce. I seem to remember a science fiction novel where there was what we would have called a theater, but it was smell-o-vision or something like that. Does that sound like it's even worth further pursuit, or is that just not likely to produce anything useful in terms of creating virtual worlds that seem more and more realistic?
I can address that because I've worked on that. Olfaction has a different quality than the other senses in that it's combinatorial. There's a little over 1,000 antecedent molecules that have dedicated receptors in the olfactory bulb, and combinations of them in different quantities translate into the sensation of different scents. It's fundamentally combinatorial instead of spectral. And in fact, one of the basic science things I used to work on and published about, 20-something years ago, was the notion that the olfactory bulb was actually the source of human language, that grammar and grew out of the combinatorial processing of olfaction, because you can, in the evolutionary tree, you can see it bumping up against the parts of the brain that turned into language. And there's a whole interesting thing about that smells were the first words. But at any rate, there is an industry that has real-time scent synthesis, which is the perfume industry. And there's a couple of competing devices, mostly located in the south of France, around Grasse and other places like that, where you can dial in different scents and then have them sent to you. The ambulatory ones that have been prototyped have a very limited number of antecedents and aren't that useful. So in a way, it's a little similar to the haptic problem, that if you're willing to be stuck in one place, you can have much more experience than if you have an ambulatory device. As a practical matter, if the way you're doing scent synthesis is by actually providing molecules to the olfactory bulb, the problem is clearing them out more than presenting them. That it's difficult. So in the real world, the way we explore plumes of scent in the real world is actually quite sophisticated. For instance, the two nostrils alternate in constricting in order to get a sample, so that we have a sort of a slightly 3D way of sampling the olfactory environment. There's a whole bunch of very complicated stuff about it. And in the real world, we have a way of disposing of what we've just smelled that's very hard to support with instrumentation and remains something of an unsolved problem. Anyway, this is a whole interesting and long topic. But the other question, is it important? Quite possibly. I'm very interested in mnemonic enhancements. So for instance, the memory palace effect, where if you put something in a specific place in an environment, it's easier to remember it than most other ways of organizing thoughts in the brain. But similarly, as per the famous Madeleine in Remembrance of Things Past, scents are marvelous anchors for memory. And so in principle, there should be a cognitive benefit. It's going to be a lagging instrumentation. I expect us to have a feeling of maturity about visual instrumentation that we don't yet have long before we have it for olfaction. Now, I've also done a food simulator where you bite into this weird thing that can change shape, and that's another thing that's quite distant and of maybe questionable value, but it's not impossible. directly stimulating the nervous system to create sense is this might be one of the in most cases. I think direct stimulation of the nervous system is always going to be inferior to doing it with a external instrumentation, because the brain is built around sense organs. It's not that abstract, but in this case, the difficulty might suggest otherwise. For a while, there was a controversy in the olfaction science world about exactly how olfaction worked. And one of the theories would have led to easier direct stimulation of the olfactory bulb than the other theory. But unfortunately, the other theory is the one that's winning, which so that's a whole other interesting long controversy. So this is another giant world that, I can only barely touch on. But I think the basic answer is potential value, but great difficulty.
So we're going to run out of time in just a few minutes. So thank you, by the way, Jaron, for that. I'm just sitting here thinking, maybe if we ever get to the point where we have direct nervous stimulation of the sensory systems, which we do with audio today with a cochlear implant, for example.
Sure.
That we actually have the ability to interact with the sensory systems in a more direct way. And I don't think we have any way to deal with cognitive interactions, because we don't understand how those work. Well, at this point, I think maybe we should try to wrap up. Let me just say thank you to all of you for taking the time to stimulate our thinking, especially 20 years hence. I hope this video stays around that long so that people look back on 2023 at what we anticipated and decide whether or not our imaginations were sufficient to the challenge. And almost invariably, if each of you looks back over the last 20 or 30 years, you might discover that where we are today indicates a failure of imagination 20 to 30 years ago, and that our capabilities will have advanced in ways that we can't anticipate. But you've certainly given us all food for thought. Greg, I'll handle it back to you. We have just a couple of minutes left before we take our next break.
Well, this definitely will be archived so that we have it for long-term preservation, if you will. It's going to go into the category of our visions of the future. On the website, we have all the visions of the past, and slowly over time, I guess it'll move from the one category to the other. Thank you again. This has been just an amazing panel. It raised so many questions that are going to be follow up with a continuing discussion on Discord and in other venues. So thank you very much. And with that, we will end this session and clear the way so the interpreters can get a little rest before the next one. Thanks again, everybody.
Really great to see you all.
Thank you.
Jaron, great. Andy and Varshney, great. Vint, thank you very much. See you.